The next topic associated with it is called electric dipole. Electric dipole, okay, dipole, that is we are talking about two poles. Okay, in this condition I am saying that there are two equal and opposite charges which are separated by a small distance. Two equal and opposite charges means it can be plus q and minus q with a small distance between them, let's say r. Now the example for it is water, that is H2O. H consists of positive charge, O consists of negative charge. So it also forms a dipole. If I have to calculate the net charge at the center of the dipole, now there are two dipole, plus Q and minus Q. The center of the dipole is represented by point P. Now we have to find the net charge at point P. So in this condition, we have to add plus Q and minus Q. The answer is 0. That means on concluding, we can say that the total positive charge at point P is 0. There are two important terms associated with electric dipole. The first important term is dipole field. Dipole field means the space or the field which is created by the electric dipole. Now, look at the same diagram. This is the diagram which already we have seen it. Okay, plus Q minus Q with electric line of forces surrounding it. Now, in this diagram, you have seen that there are electric lines of forces surrounding plus Q and minus Q. So that means there must be some particular area in which these electric lines of forces need to get confined. Now, if I ask you a very simple question that, have you ever seen a magnet and try to hold a magnet in one hand and take some iron pin in another hand and put that iron pin away from the magnet? Do you feel any force of attraction toward it? No, we are not going to feel it. Now, if we are going to place this magnet with that of the iron nail near to it, then yes, we feel the force of attraction. So what do you mean by this statement? I mean that there must be some space or area around a particular charged body. It can be electric, it can be magnet as in my example. So the area around any charged body in which if another body comes, then it feels the force of attraction or the force of repulsion. Okay, now in this diagram, if there is a positive and negative charge, and if I take a very small test positive charge near to the positive charge, in that condition there occurs a force of repulsion. And if that same positive charge is brought near to the negative charge, then there exists force of attraction. That means if that smaller positive charge comes under the area of the dipole field, then only it experiences the force of attraction or the force of repulsion. You can also understand it by a small example. Try to stretch your hand by standing in one place and there is some object which is beyond your reach. Can you hold that object? No, you cannot hold it nor you can touch it because that object is beyond your reach. Unless and until you will step forward or you will come closer to that object, then only you are going to pick that object. So we can conclude that that object is not in the area of yours. That's why you cannot pick or touch that object. Same way, the dipole has also a particular area around it where the force of attraction or the force of repulsion is experienced. The second important term is the dipole moment. The dipole moment is notified by small p with a vector sign on it because it is a vector quantity. So this dipole moment basically represents the strength of the electric dipole. It is represented by a small formula, that is P is equals to Q into 2L. Q. What is Q? Q is the charge on any electric dipole. What is 2L? The 2L is the distance between plus Q and minus Q. So this is a very small formula for the dipole moment. Now let's start with the electric field intensity on the axial line of an electric dipole. This is a very important topic and it frequently comes in your exams. So this topic is very important for you, so study carefully. Now, in the case I am asking you to derive the electric field intensity on the axial line. So you should know first what is this axial line. Axial line basically means along the axis. Okay, if suppose any object lying on a horizontal plane, so that means that that particular object is on the horizontal axis. If some object lies on a vertical plane, so according to that object, the axial line or the axis is vertical. So now we have to say that what is the axial line in the case of electric dipole. Now, what is electric dipole? We have already discussed. These are equal and opposite charges separated by some small distance. Now, in this condition, let's take two equal and opposite charges, okay, minus q and plus q. So they form a dipole. Now, minus q is placed at point A and plus q is placed at point B. The distance between A and B is given as 2L. The whole length between A and B is given as 2L. So this is what? This is your electric dipole. Now, you have to find the electric field intensity on the axial line. Now, look at carefully this diagram. Minus q and plus q lies along this horizontal axis. So, what is the axial line in this condition? The axial line in this condition is your same horizontal axis. So, this is your horizontal axis and it becomes your axial line. You have to find electric field intensity. So, let's consider a point on the axial line that is represented as, let's say, point P. Now, if you have to find at point P the electric field intensity, so you have to consider all the corresponding electric field by the electric dipole. Now, in this condition, first let's see that at the center of this dipole, this is the center of the dipole, let's mark it as O. O becomes the center of the two dipole, that is between minus q and plus q. So, what is the distance? Now, this distance becomes L and this distance also becomes L because the total distance is 2L. Now, in whatever case we have discussed till far that there is a very important term which is attached to the electric dipole and which we called a dipole moment, and this is a vector quantity. It has a particular direction from minus q towards the plus q. So what is the direction of dipole moment? The direction of dipole moment is from minus q to the plus q. Now, electric dipole, minus q and plus q, they are not vector quantity. In order to represent the vector quantity of the electric dipole, we have to take the help of a dipole moment. So now this is all the work. We already have made our base. Now, first is the condition when you have to find at point P the total electric field intensity. So you have to consider first the plus q charge. If we consider the plus q charge, then what is the electric field exerted? Obviously, it is plus q, and at point P, if the electric field is calculated, so it is away from the point P because it drives point P away from plus q. So what is the direction of the electric field? It is represented by E1 and it is away from P because plus Q is pushing P away from it. Apart from that, if at point P we consider the electric field intensity by minus Q, so what is the direction of that particular case? In this particular condition, the direction of the electric field intensity is towards minus q. Why? Because minus q means attraction. So, minus q has a property of attraction. So, it is pulling plus p towards it. That's why it is represented as E2. Okay, and the direction is towards minus q. So now you can see that at point P we got two electric field. One is E1. E1 is produced by the charge plus q. Second is E2. E2 is produced by the charge minus q. Now we have to find the two electric field intensity. First, let's start with E1. Okay. In the case of E1, I am talking about the magnitude. That's why I haven't mentioned the vector quantity. What is the formula for electric field intensity? It is K Q upon r square. R is the distance between the 2 points. In this condition, if I talk about even, let's say the point that is P, it is separated by the point B with a particular distance. So the distance in this condition now becomes BP square. Okay, this is the distance from B to point P. Now K is a constant which is represented by 1 by 4 pi epsilon naught. Q is the charge, that is plus Q. Now what is BP? Just look here. If suppose the distance between the center of the electric dipole and the distance of the point capital P is separated by a particular distance, let's say R. Okay, so the distance between O and P is given by R. So now from the diagram you can tell me that what is the distance between B and P. Obviously it is easily done because this whole distance is R, this distance is L. So BP now becomes R minus L. So this is what BP, and we substituted directly, that is R minus L whole square. This becomes the equation number 1. Similarly, you have to find the value for E2. E2 also has the same formula, KQ upon R square. In this condition, E2 is the electric field intensity which is produced by minus Q. So the distance between them is AP. So what is the distance? It is AP whole square. Now K is 1 by 4 pi epsilon naught Q. In this condition it is minus Q, but we are considering only the magnitude, so no minus sign is allowed in this condition. Similarly AP. Now work on the value of AP. Look here, it is R. OP is given to you R. OA is given to you L. So what is the whole distance? AP now becomes R plus L. So this is the distance now from A to P, and substitute this value directly. You will get R plus L whole square. This becomes equation number 2. You have to find the electric field intensity at point P. I mean, you have to find the electric field intensity at point T. Now, E1 is going towards the right, E2 is going towards the left. So, what is the net electric field intensity at point P? This would be not the addition, it would be the subtraction between the two. So, now it becomes E1 minus E2. Okay, these are the vector quantity, but we have calculated the magnitude. So now, if you have to find the resultant at point P, so subtract equation 1 and equation 2. On subtracting, you will get 1 by 4 pi epsilon naught multiplied by Q R minus L whole square minus, what is E2 now? E2 is 1 by 4 pi epsilon naught Q upon R plus L whole square. This is what you will get when you put the value of 1 and 2. Now take the term which is common. Q upon 4 pi epsilon naught is common in both the cases. You are left with 1 upon R minus L whole square minus 1 upon R plus L whole square. Now solve this value. You will get the answer, that is Q upon 4 pi epsilon naught. On solving it, we will get 4RL. So this is the resultant at point P. Now rearrange this equation a bit. In the case, if I am going to rearrange this equation, so can I write it as, take R, okay, outside, and 2 also outside, and decompose 4 into 2 parts, that is 2 into 2 also gives you 4. So I have written 4 as 2 into 2. It is multiplied by Q, it is multiplied by L upon 4 pi epsilon naught. Now 2Q into L. You have some thought in your mind that this particular value resembles to some formula. Yes, we have already discussed upon it that 2Q into L resemble to the formula of a dipole moment. That is, the dipole moment is given by P is equals to Q into 2L. Now here also we'll get 2Q into L. On putting the value directly, you will get 2R into P upon 4 pi epsilon naught. So this is the total electric field intensity at point P.